Hello and welcome. Thank you for joining the California State Library's Government Publications section for a special program on watersheds and forest succession at Cuyamaca Rancho State Park. The California State Library is thrilled to partner with California State Parks to present today's program. My name is Emily Mackinson, and I am the host of today's event. I am a librarian in the Government Publications section of the California State Library. Our moderator today is Emily Blodgett. She is also a librarian in the Government Publications section. Emily B. will be monitoring our Q&A box for any questions you may have and will read your questions to our speakers during the Q&A session at the end of the presentation. Before we start, I have a bit of housekeeping to go over. As I mentioned before, if you have any questions at any time during the presentation, please type them into the Q&A box. We will read your questions to our speakers at the end of the presentation. This presentation is being recorded and will be posted to the California State Library's YouTube channel in the coming weeks. We will email the link to everyone who registered for this program when the recording is available. Live transcription is enabled. Click the CC icon to show the captions. If you run into any technical difficulties during the presentation, please put those in the Q&A box and we will do our best to help you troubleshoot. And finally, we have added some links related to the California State Library and the California State Parks in the chat window. For any state employees without a library card, please consider applying for one through the online application link. And now on to our main event. Our speakers today are Brianna Pinto and Will Meist from California State Parks. Brianna is a state park interpreter focused on connecting K through 12 students to Anza Borrego Desert and Cuyamaca Rancho State Parks. Her role as a volunteer educator in zoos and wildlife centers inspired her to obtain a Bachelor of Science in Wildlife, Fish, and Conservation Biology from the University of California, Davis. Before joining California State Parks, Brianna worked as an environmental scientist coordinating wildfire fuel management projects on public lands. Today, she delivers free field trips through the California State Parks Ports program, allowing her to share lessons learned in local ecology with students both virtually and in person. William is a state park interpreter at Cuyamaca Rancho State Park and Palomar Mountain State Park. His time getting lost in the chaparral and canyons of San Diego inspired him to pursue a Bachelor of Science in Earth Science at Cal Poly San Luis Obispo. Will spent a few years working in the beautiful and otherworldly Guadalupe Nipomo Dunes complex as an outdoor educator with underserved students until moving back to San Diego to support family. Will joined California State Parks as a seasonal interpreter for Palomar Mountain State Park in 2017, where he gained a newfound appreciation for the incredible natural resources of Southern California, as he delivered programs like Junior Rangers, guided hikes, and campfire programs. Will promoted to State Park Interpreter 1 in 2023, where he took on the role as Interpreter 1 for the district's sister parks, working closely with partnering nonprofits, tribal communities, and fuel management teams. Please join me in welcoming Brianna and Will presenting live from Cuyamaca Rancho State Park.
Hello, everyone. How's it going today?
And
My
hello. How is everyone doing?
my name is Brianna Pinto,
And my name is William Meist.
and as Emily mentioned, we are both interpreters here in Cuyamaca Rancho State Park.
Yes, and we're here today to talk to you about the watersheds of Cuyamaca Rancho State Park and the recovery after devastating Cedar Fire in 2003, which both Brianna and I have pretty fond memories of. Well, I don't want to say fond, but
Yeah, some of our earliest memories growing up in San Diego have to do with that fateful Cedar Fire back in 2003. I can vividly recall standing outside my home and watching flames and glowing over hills outside and running back inside to see if evacuation announcements had been announced yet.
And I had a really similar experience, just like Brianna. Everyone in my neighborhood went up to the hill. We set up chairs and we could see the flames burning for miles away. So even, you know, at night, and it was just a really profound, a profound time. It was the day after my birthday. It was a very memorable birthday for me that year in 2003. But it definitely, it shaped, I guess it inspired us and it shaped our education and our desire to do this line of work. So
And it certainly shaped the landscape here in Cuyamaca Rancho State Park as well. So if you haven't caught on by now, we do want to issue a quick advisory for anyone that's sensitive to discussions of wildfire or any imagery associated with that. That is going to be a pretty heavy topic in today's presentation. But before we proceed, we should probably let these folks know where Cuyamaca Rancho State Park is in
right.
California. So while Will's getting set up in a different section of our presentation area today up here on Cuyamaca Peak, I'm going to share a map showing you exactly where we're coming from today. So this is a map of California with Cuyamaca Rancho State Park highlighted right down here in eastern San Diego County. And so we are in the mountains, kind of centrally located within the county, about a 40-minute drive from the city of San Diego, and a really great resource for folks that are looking for a refuge from the city. And Will can tell you a little bit more about the recreation opportunities that we have here in the park.
Okay. It should be showing me now. All right. I've moved over to give you guys a little bit of a better view of Cuyamaca Peak here at the top. So at Cuyamaca Rancho State Park, we have multitudes of things for folks to do here. The day use activities include everything from hiking, picnicking, to more long range treks where people practice backpacking a lot of the times. The Pacific Crest Trail comes through this area, so lots of people practice for that. We also have mountain biking and equestrian trails as well. And there's also camping. We have two campgrounds, the Paso Picacho campground and the Green Valley campground, and they both have about 100 sites each. So we're a very active campground. We're a very active park for San Diegans of all varieties. So I think we're going to talk a little bit about what Cuyamaca looked like before the fire. So let's see here. It should be transitioning, right, Brianna? Okay. Brianna's getting that. Good. Okay. So yeah, Cuyamaca Rancho State Park is the dominant vegetation is something we call mixed oak conifer forests, which means that we have, you know, exactly what it sounds like, a mixture of oak trees and a mixture of conifer forests. And it supports a wide variety of different understory and mid-story plants and animals, like birds, mammals, other plants and you know, funguses and stuff like that. But it's pretty much the dominant vegetation type here. You know, as you look out, it's very obviously a mosaic of oak trees and conifer trees like ponderosa pine, Jeffrey pine, big coat Douglas fir, cedar. Incense cedar is probably one of our most common species here. So I want to show you guys a aerial, or rather a satellite image of what Cuyamaca Rancho State Park looked like prior to the fire. So we have 9 years before the fire here in May of 1994. And if you could direct your attention towards the left side of that screen, you might be able to make out Cuyamaca Peak. And that's actually where we are located today. We're located slightly down slope from the peak itself, but we're up there near Cuyamaca Peak. And then also I'd like you to try to direct your attention to the more on the right side of the screen, where you might see a highway running across, running down, you know, up and down. And it also says Paso Picacho Campground. So generally, this landscape, this aerial photo is showing just the extent of the mixed oak conifer forest on the slopes, on the eastern slopes of Cuyamaca Peak. You can see that there's definitely some meadows mixed in there and some chaparral as well. So we had contiguous forests, but we also had a different a variety of vegetative habitats here at the park. So let's move to July 2003. This is 3 months prior to the fire. So if you compare those two, you might be able to notice some changes and maybe a little bit of the tree distribution. Maybe the grass, it looks like it's a different time of year, so the grass might be a little bit greener from a springtime. But let's move to later that year, later that year, December 2023, 2 months after the fire. You can see just how much devastation and destruction that happened here at the park. So Cuyamaca Peak on that lower left-hand side of the screen, some of the trees did survive up here, but as you can see, a lot of the trees that didn't actually get burned, they still died from the heat, the intensity, and the lack of resources following the fire. And also, if you direct your attention down towards Paso Picacho Campground, that area was also left untouched, thankfully. Now, Cuyamaca Peak was left untouched based on the geography up here and also the wind patterns. The fire was not able to actually, drop a spark or create a spot fire. It basically skipped over the top ridge of Cuyamaca Peak because the wind was so intense that it actually caused the flames to blow completely over the stand here. And then down at Paso Picacho, we had our resources crews down there and lots of fuel breaks that are made with roads. So it was a very easily defendable area down there. So as we move, so this right here, this shows on the ground just the absolute devastation of the area. Complete moonscape. So total crown fire and total destruction. Now in October 2004, it does look like things might not have been that bad, but let's just keep kind of moving through these slides here, Brianna, and you'll start to see that the dominant vegetation shifts drastically. And those two stands are pretty much the only remaining stands of mixed oak conifer forest, at least in this region. I highlighted this portion, number one, because this is where we are standing. Number two, these are two of the main stands that were able to, keep intact after that fire. And it also just, if you look at these photos, you can see that habitat conversion from a mixed oak conifer forest to a sort of grassland chaparral type habitat vegetation. So I'm going to give you guys, I hope you guys sort of enjoyed taking a look at some of those aerial photos. Hopefully they came in well enough for you all to be able to make out some of those details. So that's a little brief history of how the landscape changed up here. But I want to take a quick step back and sort of give you guys some natural history on Cuyamaca Rancho State Park. So a little bit of geology and a little bit of climatology that will help set us up for the rest of our webinar. So we're at the very northern tip of the peninsular ranges here in terms of geology. So if you think of Baja, Mexico, the peninsula that stretches all the way south, we're at the very northern tip of that sort of geologic region. It's characterized by mostly granitic rocks. There are some sections of sedimentary rock and also some metamorphic rock, but it's predominantly granite, tonalite if we're going to be specific. But Cuyamaca Rancho State Park and much of these mountains in the east side of San Diego County are characterized by a high amount of uplift, and we have very, very steep slopes on the flanks of our mountains. So we have lots of waterfalls, we call them nick points in geology, just places where water flows down off of a fall. And we have lots of rock slides and lots of landslides too. So that's a little bit about geology. The climatology of sort of California as a whole, if we look back about 20,000 years ago, the last glacial period, the Ice Age, we've been in a warming trend ever since. So based off of geologic evidence and vegetative evidence, we've seen that a cooler and wetter climate has shifted to a warmer and hotter climate. And then in that, we have seen vegetative shifts as well. Mostly, it's three main changes in what we've seen with the vegetation from this climate change. You see a shift in north-south distribution. So you'll see species that require a wetter, cooler regime migrating north in latitude, let's say further up, further north in California as the climate intensifies. You've got vertical shifts in the elevations of certain communities. So let's say a stand of trees that was previously able to survive at lower elevations now has to be at higher elevation to get that same amount of water and that same those same cooler temperatures. And then we have population contractions and expansions in some areas. So you'll get areas where some populations have completely dwindled or are gone entirely, which we call extirpation. And then you have other areas where that become refugia, places where those conditions still exist, where the communities are able to thrive, much like Cuyamaca Rancho State Park. We happen to be in a refugia area up here. Okay, so now I'd like to give you guys a little bit of a different perspective. So I'm showing you sort of here, I hope you guys can see everyone, not just you guys, you gals, and everyone else who might be attending with us today. This contiguous sort of treescape that we have up here. These are, I want to say, relatively like 30, 40 years old. Some of these trees might be in their 70s or 80s. And now I'd like to show you a very contrasting view. So while I'm getting that set up, I think we're going to set up another slide here to sort of give you an idea of what causes Cuyamaca Rancho State Park to be a refuge. So the orographic effect, if you're super nerdy, you probably already know about this. Congratulations. But the orographic effect or orographic uplift, it's basically just a fancy word or a fancy scientific term for air getting pushed up against mountains. So oro meaning mountain, graphic meaning the air is moving up along the mountain's side. Okay. So the warm, moist air, it rises and it cools as it's pushed against the mountainside. It precipitates and it rains. And all of that moisture is dumped out into the mountain range before it keeps moving along with no more moisture left. And it leaves a rain shadow. And that is exactly what is going on here in San Diego. So I'm set up now. Oh, I have to switch my camera for you guys to be able to see the gorgeous view. Okay, so now I'm showing you the flank of Cuyamaca Peak. We've got this gorgeous landscape, but not a lot of trees, really, mostly chaparral. And as you look out there, it's very rugged. You can see a lot of the mountains are, you know, there's rock outcrops all over San Diego. It's a very rugged, it's a very rocky landscape. We got a nice, warm, sort of overcast day today. And hopefully you guys can see these nice fall colors. It's a little bit washed out with the lighting right now, but hopefully you can still see it. It's a gorgeous fall day up here today. So and that's the ocean out there too, you can kind of see it. All that water moisture, it comes this way, it gets blown this way by the wind, by the prevailing winds, and it comes up against these slopes, and that's where the orographic effect comes into play. And that's why we get so much more rainfall up here in Cuyamaca than the rest of San Diego. And that sustains the mixed oak conifer forests up here. Okay. let's see, where are we next?
Thanks for that beautiful look out to the west, Will. I'm hoping you can speak a little bit more to how then Cuyamaca plays into the watershed. So I'll bring up some maps for you to talk a little bit about where that water all ends up then that falls in Cuyamaca's precipitation as rain and snow.
Okay, perfect. Thank you. So yes, we're going to talk about the watersheds themselves because this webinar is about watersheds, right? Right. So that's a nice, beautiful map of the San Diego watersheds. We've got a really, really interesting sort of geography here in San Diego, but I want to sort of direct your attention to two of those watersheds in particular, the San Diego watershed and the Sweetwater watershed. The Sweetwater watershed. So those two right there, those are the two, sorry, I'm moving at the same time, folks. Coming back over to my spot. Those two watersheds are the main ones that the Cuyamaca Rancho State Park presides within. So if you look up in the top sort of right-hand corner of the screen, there's Cuyamaca Lake. And that's right there within our park. And there's also, so I guess they have the two main water courses that flow out of Cuyamaca Rancho State Park is the Sweetwater River and the San Diego River, both of which flow into, I think, at least one, maybe more reservoirs. There's two major ones. And I think it's really just it's very important that we keep in mind that, you know, water quality, it starts at the top, the very, very tippy top of the watershed. And as you can see, we are the origin point for two major watersheds in San Diego County. So all of the water quality that we have up here, or the quality of our water, it only degrades as you go downstream. So we need to, we strive, and I think we do a pretty good job of ensuring that our watersheds are very clean and very, just high quality water coming downstream for the folks of San Diego. Okay, so I think we're gonna transition a little bit. Oh, okay, here, let me turn this. So now I've given you guys a little bit of a background on the natural history and some of the other sort of, let's see, yeah, the natural history, some of the geologic history. Now I'd like to talk to you a little bit about our cultural history, because that actually also has a massive, massive role to play in sort of how things have changed here in Cuyamaca Rancho State Park. So from time immemorial, and I'm sure that we've heard this all throughout California, it's a great story that we've all been bringing to light more, but it's the same thing here in Cuyamaca in Southern California. We've got, from time immemorial, the Kumeyaay tribes. The Kumeyaay tribes have been utilizing the natural resources of this landscape for millennia. They're highly in tune with how it functions and how they can get their resources from it, but also something that we call cultural burning. Some of you may have heard of that term before, but it's basically just when when folks would go out and they would set fires on purpose. And they did that to, no, number one, it actually deposits a lot of fertilization. So as the area burns, a lot of fertilizer is deposited, and it allows more plants to use that fertilizer and come back more rich, more in more numbers. It encourages grasses, it encourages forbs growth, which the tribes could then use to harvest themselves, or it would attract animals in, and then they would, you know, kill those animals and use them for resources. So cultural burning has been something going on in California for thousands of years. And as you would expect, it had a big effect on the landscape. So moving a little bit forward in time with Cuyamaca, in 1845, we had the arrival of the rancheros. The land was given over by Governor Pio Pico as a ranchero in, what was that, 1845, right? And then in 1869, he actually gifted the land back. And that was the exact year, I guess 1 year later, the Julian gold rush happened. So we actually have our own little mini gold rush down here in Southern California, right here in Cuyamaca Rancho State Park in Julian. And that was in 1870. So between 1870 and 1933, when Cuyamaca was established, you had it being used as sort of like a resort and a mining station until 33 came around and it turned into a state park. Okay, so a little bit about, oh yeah, I kind of talked about that, yeah. Oh yeah, I wanted to mention, I guess, just how it's changed, right? So you had the tribes existing on this land for thousands of years, and then all of a sudden you had the arrival of the Spanish, and they stopped that activity. They put an end to cultural burning as they seized lands and stopped that activity, right? So what you had was a landscape that was getting frequent fire intervals. So fire coming through, burning the landscape, reducing the fuel, to suppressing and completely putting out fire. And we did that for a long time. You do it to protect people's property, you do it to protect their livelihood, but it has a secondary effect, right? We want to try and protect their lives and their property, but it also creates this large amount of fuels that get hotter and drier as time goes on, and that creates the conditions where mega fires can form. So you don't just have these small fires burning at low intensity, you have a massive amount of fuel and a massive fire that results as that comes about as a result. And this is a story that many of us are familiar with in California. So I want to just sort of highlight some of the different fire regimes, some fire regime data, I suppose, to give you an idea of a normal sort of, let's say, normal fire regime. So if you take a look at this table here, I'll sort of explain it. The top there says vegetation community, so that's just a description of what kind of vegetation we're looking at. The fire severity, that could be anything, excuse me, that could be anything from like a low intensity fire, a mid intensity fire, to a destructive fire, so replacement. And then fire regime characteristics, percent of fires, meaning like how many of those fires are replacement fires? How many of those fires are mixed fires? How many of them are low or just surface? And then you have intervals, which means like the return rate. So that's just how long it takes for a fire to happen, one after the other. So I wanted to highlight this to give folks an idea. If you look, let's say, the California grassland, 100% of those fires are replacement fires, meaning that 100% of the vegetation is burned and replaced in the event of a fire. And I won't go too much into the intervals, but it's a very short interval. So you'd expect that, right? Grass burns easily, there's not a lot of it, so a full replacement is to be expected. Now, if we look at something like chaparral, we've got that highlighted for you. That's another type of vegetative community that you would expect to see 100% replacement with. They're highly flammable fuels. They're really co-evolved with fire regimes. So they're extremely good at burning in fires and then returning just a year later, extremely, I guess, in high numbers and with they're very good fire return species. Ceanothus. And then I wanted to highlight this one because now we start to see the numbers shift, right? So a California oak woodland, the replacement percentage goes down to 8%, which means that only 8% of the time you would see a full replacement. So these fires that come through these areas, they typically burn on the surface or they're very low intensity, meaning that a lot of the trees will survive, if not all of them. And so now we're on to our final sort of section here, where these communities are very comparable to what we have in Cuyamaca Rancho State Park. Now, this data is not 100% like applicable to what we have here, but it is very comparable, these vegetative communities. So Jeffrey pine, mixed conifer, like we were explaining, mixed oak conifer on north and south slopes, and then mixed evergreen, big cone Douglas fir. All four of these are sort of communities that we have here, a mixture of them in our parks. And as you can see, those replacement numbers on Jeffrey pine, mixed conifer are very low. It's a little bit higher when we get to mixed evergreen in the big cone Douglas fir in that southern coastal section, but it's still not even 30%. So what this is highlighting is that in a normal fire regime, in a fire regime where our climate is not overheated, where we are not experiencing drought, where fuels have been regularly burned and have not been built up over several decades, you will see some replacement in these plant communities, but you will not see 100% replacement fires. That is a sure sign that something is very wrong with the landscape. So I hope maybe you enjoyed that little dry section, maybe not, but numbers, they can paint a very powerful picture for us. They can tell a very profound story. So I think we're going to transition now to a little bit of landscape management with Brianna.
That's absolutely right, Will. And thank you for sharing those numbers. I think those are really significant to look at how a fire affects a landscape differently when we're not looking as many anthropogenic sources of ignition and manipulation of the landscape as we see them in recent history, with the suppression of cultural burning in favor of wildfire and wildland fire suppression. So I have some neat historic photos from our early days here in California state parks. And the focus there, like you've heard before, is a story of putting fires out as they start. And so, as you could imagine, that does lead up, as Will alluded to, a buildup of fuels on the ground in terms of dead and dying material, as well as those trees. If we're not getting smaller stands of trees, like new saplings and things thinned out by regular ground fire, then those are going to be growing up in more dense numbers with more trees competing for the same or even less water than they are experiencing in regular fire regimes. And so these kinds of conditions, especially then paired with increased human use in the area, more and more people moving into Southern California with new ignition sources like power lines and gasoline combustion engines and all sorts of new variables, means that we might be in for some consequences after a good century or so of fire suppression out here. And this is a story that unfortunately we know well in California, but Cuyamaca Rancho State Park was one of the first places to really experience that lesson in the 21st century. For anyone familiar with Southern California climate and ecology out here, Santa Ana winds are probably something that sends a shiver up your spine at this point, because these are winds that blow in from our eastern deserts rather than our regular weather pattern of coming in from the west over the ocean. So those usual coastal breezes are nice and humid, carrying a good amount of water vapor in them, and not quite the same as those Santa Ana winds coming in from the desert. Those are hot, dry winds that are getting funneled down through our mountain valleys to be not only carrying less humidity, but moving at faster speeds. And fire needs fuel and oxygen to burn after an ignition has been set. So that provides a lot of oxygen, a lot of speed for that fire to move, and makes fuel optimal as well by drying out any vegetation that's on the ground. I'm probably going to be using a lot of campfire analogies in this program because we do love camping out here in Cuyamaca. And I'm sure you know that it's a really bad idea to try to start a campfire with a wet log. But when the humidity's been low, by basically setting nature's hair dryer across the landscape, then you're going to see a big difference in how easily a big fire can start. Unfortunately, we saw that earlier this year in Los Angeles, and we did see it on that fateful day, October 25th, 2003. A lost hunter sets a signal fire that ends up burning 280,000 acres of San Diego County. And as you can see in this diagram here, this is the perimeter of the fire. You might have noticed when it started that it was moving towards the ocean, out towards the west, being driven by those Santa Ana winds. But 3 days into the fire, the Santa Ana winds die down, the fire is not yet contained, and it starts moving back to the east as the coastal breezes replaces the predominant wind. So as that fire gets blown back east, it makes its way into the mountains of Cuyamaca Rancho State Park, and 10,000 acres, almost our entire park, was consumed in flames from the Cedar Fire. Despite valiant efforts, some areas were maintained, but we lost 95% of that mixed conifer forest that we were talking about, that we see this last remnant here where Will is standing. And so this was a devastating loss for the folks of San Diego County in so many ways. There were multiple fires going on during this time, which did affect response times because lots of crews were deployed elsewhere, meaning that the total effect on San Diego County of these firestorms over this 2-week period that it took to contain them was that 13% of San Diego County burned. 17 lives were lost, over 3,000 buildings were lost as well. And what you're seeing on screen now is the perimeter of the 2003 Cedar Fire in red, and in green is Cuyamaca Rancho State Park, just about entirely consumed by that fire. And as such, this fire was the biggest on record at the time in California. So it really began to change public understanding and perceptions of wildfire. It wasn't as commonplace for this kind of occurrence to be happening back then as it is today. So as a result, we saw a lot of differences then in how we began to treat fire. It led to changes in our firefighting techniques, as well as giving a lot more resources towards those aerial attacks, changing the dynamics of when those can go out. And since then, in the last 22 years, we've gotten a lot of advancements in technology, not only for the surveillance of fires as they occur, but also for predicting when those conditions might lead to unfavorable outcomes for folks. And so that's one reason why a lot of us have experienced now a power outage related to high winds, because when those power lines go start blowing around, they can cause one of those pretty dangerous sparks. But of course, we saw that fire not only changed public consciousness, not only changed the lives of people living down here in Southern California forever, but it also changed Cuyamaca Rancho State Park, likely for the rest of our lives, but not all was lost. So I've got a few more slides to share. This is coming from our high performance wireless research and education network. This is regional fire towers that, camera towers that are used in early wildfire detection and response. And they actually captured a really interesting time lapse of how the landscape changed here. So I know we saw some aerial imagery earlier. This is where we were on the ground just 2 months after the Cedar Fire, like you saw with that almost charred looking landscape. But what we didn't see is it only took about 8 months, just one nice spring with plenty of precipitation for lots of vegetation to come back. So we might not be seeing the forest at this point, but we know that forests don't grow in a day. But I'm not sure if you've ever gone outside and noticed that, no, maybe a new tree won't spring up in your backyard overnight, but a new set of weeds might. So a lot of these annuals, forbs, grasses can grow really quickly, and we see a lot of fire-adapted shrubbery out here in California that can spring back up after a fire quickly as well. And that's provided a lot of the greenery and the landscape since. If you look behind me towards Cuyamaca Peak, you'll see that's what dominates the landscape at this point. Lots and lots of bushes and shrubbery, and you'll see that that's the story in the decades of images that we have to come here. Sometimes you also might notice it receding. We'll talk about that in a moment. But for the most part, we're getting shrubbery growing back with a vengeance. And so that's kind of unique here in Cuyamaca because of where we're set up in the watershed. So Will, if you want to add on to how what we talked about earlier with our unique geography is helping us to recover now.
Most definitely. Yeah, it's pretty incredible recovery rate there. Almost immediate recovery from the chaparral. And now it's time for us to sort of tie together all these concepts, right? We've been talking to you a little bit about geography, geology, a lot about fire. that's a lot about what this is about. It's about how this watershed up here in Cuyamaca has allowed the landscape to recover. And it's not a full recovery because, like Brianna said, in order to get back to that full forest, well, I don't know if you mentioned it, but it would take hundreds of years, right? It's not going to be something that happens in our lifetime, unfortunately. So just a couple of things that allow factors that allow that to happen here at Cuyamaca Rancho State Park was something I mentioned earlier, which is the orographic effect, right? We've got moisture, we've got that, biggest ocean in the world, the Pacific Ocean. Water vapor, water, it vaporizes, it gets, lifted into the air. It gets pushed onshore all the way out here towards the mountains, and then that's when that orographic effect comes into play. So the topography, the geography of this area is one thing that allows that catchment of moisture, that catchment of the water itself. And the oh yes, the geology of these mountains are predominantly granite, which actually as a rock holds on to groundwater exceptionally well. And it also it basically, as the water seeps out, it seeps out very slowly, which gives us a nice slow release of water throughout the year and throughout the years and over long-term periods. So you got a big surplus of water during spring that slowly leaks out of the hillsides and supplies the hillsides with all the vegetation with the water that they need. And then yes, the other thing is that these mountains basically it ties back to the watershed, or the reservoirs that these watersheds supply. So yeah, the amount of rainfall that we receive up here is vital for the plant communities, but it's also incredibly important for all of the people that live in San Diego County, because it fills those reservoirs, which supplies water for hundreds of thousands of people. So
Okay, yeah, well,
those
that's great and all, but what about the trees? Where are those trees coming from? I don't know. Like you were saying, that we're gonna get to see those trees back for our lifetimes, our children's lifetimes, because this is playing into a concept we call ecological succession, where it takes a long time for an ecosystem to recover from disturbance and come back to something we might consider a mature forest, something with trees that could be 200 years old and grown to maturity. And those things don't happen overnight. And they're especially challenging to recover from when we've lost the building blocks to get them back. So the image I have on screen now is the same sugar pine before and after the Cedar Fire. If you look at it on the left, this is clearly a pretty robust old tree. It was very large and it had some scarring from previous fires that it had survived. However, that Cedar Fire came through so fast and so hot, it went up into the crowns of trees and affected their ability to survive. So this was, as we've said, a really devastating fire, not just for the trees, but for the seed bank as well.
That is one of the most wild photos I've ever seen.
Yeah, we've got some pretty horrifically incredible imagery from after that fire, and it's amazing to see how well the landscape has recovered since. That's what's one reason we wanted to highlight this, is just it looks completely different now. It's changed, of course, in terms of the ecology, but it's still a much more pleasant place to be than it was in the months immediately following the fire. But we've lost the trees, we've also lost the pine cones. So coming back to our campfire analogies, I'm not sure if anyone's ever tried to use a pine cone they found near their campsite as kindling to start a campfire, but they'll burn pretty hot and they'll burn pretty fast. So when the fire swept through, it took everything off the ground with it as well, all those fuels down in the soil, and that included any cones that had been dropped by these trees where their seeds would have been dispersed by. So we'd then be relying on these leftover pockets of conifer trees, those few ones we saw in the aerial imagery, in order to restore the entire 10,000 acres that burned. And that's a process that could take a very, very long time that we don't necessarily have in the current era we're in, where invasive species have become a major consideration in areas that are recovering from a disturbance. So introduced plants, a lot of those coming from the ranching era, grasses that came in that were much better for cows to eat than the native grasses out here, plants people use as ornamentals in their lawn, things that didn't evolve with this ecosystem, that weren't present when this forest first arose, would have an opportunity to come in and repopulate this area once the competition was eliminated after the fire and in the years as a result. So it was essential for us to take it upon ourselves to give the forest a head start. This fire had an anthropogenic origin. A human started the fire. Humans failed to protect and steward the landscape over the century leading up to this fire. And so it is our duty now to try and give that forest a chance at recovery within at least maybe a couple generations lifetime. And so in order to tell us more about that, we actually had an interview with one of our environmental scientists in charge of the reforestation effort in Cuyamaca Rancho State Park. His name is John, and I'd like to introduce you to him now. So let's bring up our video with John.
I'm John Lovio, environmental scientist here in Cuyamaca Rancho State Park. The reforestation effort is pretty much focused here in Cuyamaca Rancho State Park because of the severity and the extent of the original burn. If you look at some of the brush areas that came back after the fire, they're very extensive, and there's no canopy to drop seed to restore the forest naturally. So that's where we've intervened. The figure that was of acres that were burned in the 2003 Cedar Fire is 10,000 acres. Our target is to restore 2,500 or 25% of the original loss. And those islands of vegetation are anticipated to, over time, spread the forest even further out between these separate islands of reforestation here. So, and this is a much longer time scale. Maybe it might take a couple of centuries for these areas to expand out and connect with each other.
Thanks, John. So that reforestation effort began in 2007. And by that point, we had lost about half of the mixed conifer forest in San Diego County to wildfires. So here in Cuyamaca, we had about 1/5 of the total forest of that habitat type. And so it was determined that a head start was necessary for these trees to have a chance at coming back. And so 5 species are being planted since 2007 with proportions based on historical surveys of what was present in the area, mostly Jeffrey pine with also some white fir and incense cedar and others in the mix. And these trees are being planted gradually in stages in order to promote a more mixed age stand. So going plot by plot through the park in order to create something that has a somewhat different outcome than maybe a forest that's being replanted for the sake of timber harvest, where you'd want a bunch of uniform trees in a straight line that are easy to make into a product. Here, our goal is a little bit different, as we're trying to protect habitat for wildlife and provide recreational opportunities for people with a minimal touch on the landscape as we go. And so John can tell us a little bit more about how this was a unique project for the Southern California region and what our outcome is through our project here. So take it away, John.
So this is a good example of what the forest used to look like. This is a remnant somewhere in the neighborhood of 80 acres of unburned forest at the edge of the campground. This is in terms of what we look for in a mature forest. Obviously the size of the trees, and collectively the tree cover is called canopy. And if it's shady, it supports a different kind of vegetation on the ground than we would get out in a meadow, for example. This is sort of dominated by pine trees here, but we also have some oak trees in here. This particular forest has cedars as well. That's one thing we look for in a mature forest, is a mix of species. And that's what we call, part of what we call biodiversity. You can see near the ground, there's this shrub cover layer here. That's adds a structural layer that different kinds of wildlife will use, as opposed to wildlife that are more specializing in the tree cover itself. So anyway, this is what we'd like to achieve in our reforestation efforts, is to come back to this example here. We have other vegetation types that we do try to promote as well. We have natural chaparral. Even though we do manage chaparral to allow the forest to come back, we have meadows, riparian zones, different kinds of vegetation that are part of the biodiversity too. If you have a larger forest, you're more likely to include those other types of vegetation. Diverse topography, north and south facing slopes, drainages. So that's part part of a resilient natural biodiverse forest.
So we're lucky to have a large area of land here that we're working in, and as well as having neighbors to the east and south and to the north of us that have a lot of land to assist with making a larger ecosystem back to hopefully an image of what it was before. But with all this, each reforestation plot does take significant effort to achieve. It's about a 2 to 3 year process for each one of these plots that we go through. And that includes collecting the seeds from trees within the park so we know that we're getting a good genetic sample for this specific ecosystem, selecting sites, doing surveys for rare plants, nesting birds, cultural and other archaeological artifacts within those areas, then getting those seedlings back and getting the site prepared through different mechanical and fuel treatment means, delivering the seedlings to the site, storing them, hardening them up for our ecosystem here, finally planting them, getting them protection from herbivores and maybe from visitors, and finally monitoring their success as they grow. So with all this effort involved, it's really crucial that we make sure that the next fire that comes through, because we know now that there will be a next fire, isn't so devastating. So it's our goal to make a resilient forest, one that's able to recover more quickly from what comes next. And so in order to achieve that, fuel management is part of the equation. So we'll hear one more time from John to discuss the kinds of specifics of our reforestation project and the fuel management that goes hand in hand with that.
But this is a good example. All our seed material comes from small remnants of forest here in the park that are shipped out to be propagated, and then we get seedlings back from a nursery at age 1 year, and that's what we plant. Those little seedlings about 12 inches tall. The reforestation part involves removal of competing brush. Now this is a natural process. When brush comes in, it becomes very dense in just a couple of years, and it actually precludes the planting of trees. So we have to go in and mechanically remove it, often followed by fire, just to reduce it. Now, it doesn't really kill the shrub cover, but sets it back and gives us a little window of time to come in and plant seedlings. And then on the other end of the spectrum, in terms of resilience, we do a lot of fuel management, and that basically involves removal of dead and down material that could spread another fire, conducting prescribed burns, basically introducing controlled fire to allow us to manage the vegetation. So fire as a helper, gradually controlling the fuel such that you prevent these large-scale devastating fires.
And so we're really fortunate here in state parks to be equipped to treat those fuel management areas and respond to fire that we're not expecting when it's not necessarily being a helper for us. So we have a fire management program within California state parks, but we also partner with other organizations like CAL FIRE to work on larger projects, because prescribed burns that we do can take up to a year to plan just to make sure the conditions are right and the personnel are there and ready. But here in Cuyamaca Rancho State Park and some of our sister parks down here in eastern San Diego, we have a unique program and a partnership with our local tribes called the Native American Conservation Corps. This encourages tribal youth to come and volunteer on California state parks projects with fuel management and reduction. And that gives them the opportunity to learn firefighting skills and have future employment opportunities here in California state parks, so that we're getting more Native voices in fire management and hopefully getting that traditional ecological knowledge shared with us as we have our fuel management planning strategies. And so we're very fortunate to have these partners, because it really is a team effort to make sure that we are able to restore what we have lost here in Cuyamaca and protect it for future generations. And so with that, I'd like to welcome you back over here, Will, because I hope that we've been able to answer the question of why Cuyamaca is worth restoring. I mean, the landscape's clearly changed, but it's still a very special place to us.
Indeed. So there's a number of reasons. Am I still on?
Yeah.
Okay. There's a number of reasons why Cuyamaca is worth protecting. First and foremost, the mention of those watersheds the map of watersheds I showed you guys earlier. You know, like we said, we're the origin of those watersheds. So the water quality up here in our park is the starting water quality for it, going all the way down throughout the watershed. So if we can protect it, if we can get more plant coverage, more tree coverage, that'll reduce the amount of erosion, the amount of particulates in the water itself.
And we also want to be cognizant again of those invasive species. So if we have invasive vegetation living up here at the start of the watershed, there's not much stopping those seeds and other material from making their way downstream into our local rivers and creeks. So we'd want to avoid that and keep our ecosystem as pristine as possible up here and in function. And this is also going to be an important refuge for wildlife as climate change has effects down closer to the coast. So we're seeing increasing global temperatures over time, and that means that worldwide researchers are noticing upslope migrations of species that are less tolerant to heat. So higher elevations can provide cooler temperatures, and we might expect to see some of those lower land species making their way up slope to try and get a little break from the heat. And so this is going to be really important habitat to maintain in the future, and even for species that we lost as well. So it's part of our mission to protect these resources. California State Park's mission is on screen now, but I'll read it to you anyway. It's our job to provide for the health, inspiration, and education of the people of California by helping to preserve the state's extraordinary biological diversity, protecting its most valued natural and cultural resources, and creating opportunities for high quality outdoor recreation. First, I want to point out the biological diversity that we touched on earlier and those natural resources. Those are really crucial for us to make sure that we're maintaining here. So mixed conifer forest, like we saw in Cuyamaca prior to the Cedar Fire, is crucial habitat for wildlife like the red-breasted sapsucker, one of my personal favorites, the red-breasted nuthatch, and guess what? This one doesn't have a red breast, the golden-crowned kinglet. So this wildlife calls this place home, and it's our job to make sure that we have suitable habitat for them to live in.
What a cute little bird.
And finally, Cuyamaca is important to people.
It is. Like we mentioned earlier, this is the ancestral homeland of the Kumeyaay tribes. So they're up here, you know, one of the main things that they try to emphasize to us is that we speak about them in current terminology. So the tribes are always coming up for traditional practices like harvesting of plants or just doing cultural like ceremonies up here. So ensuring that this landscape is well managed and it has some semblance of those resources that they had in the past, to ensure that those traditions can be passed on and that they are able to practice their cultural traditions.
Yeah, and for those of us that aren't members of the Kumeyaay Nation but still live nearby, Cuyamaca Rancho State Park is also just an important refuge from city life, right? This is one of the few large remaining green spaces, not just for wildlife, but for people to come and recreate too. And that is also part of California State Park's mission, to make sure that people have great outdoor spaces to come and enjoy.
Indeed. I don't think I could have said it any better. Do we have anything else to mention?
I hope that covers it. I think we might have a couple minutes left over for questions if there's anything that you're still curious about. But thank you so much for joining us today to find out a little bit more about Southern California's forests.
Thank you all so much.
Thank you. Thank you so much, Brianna and Will, for that fantastic presentation. We will now begin our Q&A session. If you have any questions for Brianna and Will, please type them into the Q&A box now. Emily B., did we have any questions that came in during the presentation?
Yes, we do have a few. In the video clip you played, you mentioned, John mentioned what the goal for reforestation was, that 2,500 acres. What's the current progress of that?
Yeah. So since 2007, we've managed to reforest about 1,800 of those 2,500 acres. So we're making really solid progress through that, and we've got more planned for this year. One exciting thing that is hopefully in the works, I don't want to spoil it by announcing it to a crowd, but we're hopefully working on a 100-acre broadcast burn. So that's a prescribed fire that we're planning out here to prepare a new site for planting moving forward. So we're continuing to move forward with those field treatments and that reforestation out here in Cuyamaca, and we're really close to achieving that goal.
That's awesome. So, how big are the trees that have been planted getting now? Like, are they still tiny, or are they getting up there?
I mean, it's tiny relative to the trees that have been living here a long time, but I don't know. When we take field groups out to Azalea Glen, there's some trees about my height. I'm almost 6 feet tall, and those are right along the trail there, and they're probably about 15 or 16 years old now. What kind of trees are you seeing throughout the rest of the park?
Yeah, I would say that's pretty, that is pretty accurate. I think like if I might show you, let's see if it shows up. There's a couple of trees over as I'm in the corner. Hey, what's up, everyone? There's like a tree over here. It's probably about, I want to say maybe 10 or 15 feet tall. And in terms of its diameter, it's maybe, I don't know, 6 to 8 inches, maybe a little bit less. So these trees, they grow pretty quickly. They're in there, they're very young still. They can grow up to 60, 80, sometimes 100 feet. So what is it? It's been about 15 years. Actually, no, it's been 20 years, right? We just had the anniversary a couple years ago for the Cedar Fire. And our reforestation efforts, I don't know the exact year they started.
2007. So, and again,
Okay.
it's been a gradual process from there. So not all the trees have gone down since 2007, but there's still some in other areas of the park that are still in that sapling stage or the seedling stage that he mentioned, only like a foot tall. So it varies throughout the park, and it's kind of a fun scavenger hunt. If you're out on a trail, maybe you'll see the little sunscreens that we have, that little black screen that was on the seedling in the video. That's something that helps protect the seedling from direct sunlight as it's still really small and growing, since we do treat the areas that they're going in to make sure they're not shaded out by competing plants until those shrubs have a chance to regrow as the tree gets a little bit taller and can compete.
That
Yeah.
makes sense. When their normal conditions aren't there, kind of having to substitute. That makes sense. Yeah. So with all this reforestation, is it mostly like financial and staff constraints? Like if you got some amazingly huge grant, would that help? Or are there also other reasons for kind of a slower approach, like not gathering too many seeds at once or something like that? Like, what are your main constraints there?
Yeah, we were actually really lucky in the wake of the fires to get some large donations to kind of kickstart the effort. So some of our big initial pushes were done with large grants received for that. And in the wake of a lot of the 2019 and 2020 fires, we saw a lot of legislation passed affecting the state budget and allocating more resources towards wildfire fuel management, mitigation, and projects associated with that. So we've been able to use our resources well and make them come out over time. But these are also environmental scientists that were working across three very different parks in the Colorado Desert districts down here in Southern California. So we have people working hard on them. We do rely on some outside contractors as well to accomplish these goals. But I think a big consideration too is just coming out with a mixed stage stand, right? Having a gentle touch, like I mentioned. There's a lot of involvement and intervention that's required in order to prepare a site for dropping seedlings in. And so going through all of these areas, they might not be suitable sites due to the presence of those cultural resources or other rare plants that we saw. They might be inaccessible to crews. And so letting the forest at least get a kickstart, we still acknowledge that ecological succession is a process that takes time, but at the very least, we're increasing those patches of forested islands that can take over with time. And did I cover that, Will? Is there anything you wanted to add?
Yeah, I think you covered top, head to toe right there. I just would add that I mean, I'm biased. I'm incredibly impressed by our teams by putting all of that consideration into this sort of stuff. And like John was sort of mentioning earlier, we come and we masticate to clear the area and give some of those newer seedlings, their saplings, that time to regrow. So it is a challenge. It's a huge challenge. Like Brianna mentioned, our environmental sciences team is spread over 3 parks in this district. One of our parks is Anza Borrego Desert State Park, which is the largest park in the entire system. It's almost 600,000 acres.
Over almost 700 now.
Oh, okay. I guess the
That's
number
about the size of the
continues to
state of
grow.
Rhode Island. Yeah.
So, and I mean, even in a small park like Palomar Mountain State Park, where I also work, it's very, the topography is such that it's not easy to traverse. Everything takes time in terms of getting in, getting out. So yes, it's a manpower problem. If there are any angelic donors who would like to shower us with a reforestation grant, hopefully we've convinced you today that it's worth doing and that we've got a really talented group of people that know that what they're doing down here. And it's a really good cause. So anywho.
Yeah, really grateful to our partners and volunteers for helping with that as well.
Great. So you mentioned having, more vegetative cover, kind of preventing erosion and protecting that water quality so the rivers aren't just full of dirt. What kind of effects on downstream water quality were observed like shortly after the fire compared to now as some of the plants are starting to return?
It's a
I
really
don't
fascinating
have any
question.
particular data. I would imagine, and I mean, I can only say this from anecdotal evidence. I don't really have like anything to point to, but the landscape destabilizes to a point where almost any rain will cause mudslides, landslides, and a lot of that soil is going to end up in water courses and eventually into reservoirs. And it really takes a toll on reservoirs in general because as you get sedimentation in reservoirs, they can start to build up. They can start to actually fill and they'll need to be dredged. So, as far as the like specific deleterious effects, I can't point to them, but generally, I think that's what we experienced here.
Yeah, well put. Hope
Uh,
that answers your question best we can.
yeah, is there some sort of data collection center that people could look up if they wanted, either for the water quality or for the biodiversity tracking efforts, anything like that?
Yeah, as far as water quality, since that's going to be going outside of our park, once you get to the reservoirs, I would check in with your local water authority. So the people managing the Loveland Dam, the Sweetwater Dam, and the Sweetwater River area. That's the Sweetwater River Authority or the Sweetwater Water Authority. And then San Diego River is kind of managed by a couple different water authorities. So it'd be my guess that if somebody has that data, it's probably going to be those folks, just because then that's downstream of us. We're at the origin point here, and water quality is looking pretty good. As far as biodiversity data goes, that is part of the ongoing effort as well. I think that's a lot of where John got involved. He's actually an avid birder, knows a lot about the avian fauna in the area, and has a lot of forestry background as well that brought him to this role. But if you'd like to get involved with contributing towards that data, we actually really welcome community science projects.
I
Like
was
we have
just
an
gonna
iNaturalist
say,
page. Yeah. Yeah, Will, you want to tell more about iNaturalist?
iNaturalist is like my new favorite thing. It's
Will's a
if you
great bio blitzer.
it's I found out it's a really good tool for like, the public, for any citizen to just log in. You type in the name of the area you're looking for, and you can just type in search area Cuyamaca Rancho State Park. It'll come up with our boundary and everything, and it will show you how many people have made observations there. And this is a big citizen science sort of effort. Many of you have probably heard of iNaturalist. Some of you may not have, but I have found it to be an incredibly good resource for learning more about the different species that live in these parks. We have tens of thousands of observations from people that come to these parks because they're curious about what they're seeing. They upload it, and then we get a data point. Boom. So it's actually, I mean, it's probably one of the better databases out there in terms of like photos, distribution. It's actually incredible. It's actually
Yeah.
incredible.
All it is, it's just a free app you download on your phone. You snap a picture of any living thing that you see, and you can either make a guess about what it is or wait for these really active volunteers on there to contribute their pretty informed guesses on those. And once those are confirmed by enough people, researchers like our environmental scientists in the park can actually use that data in scouting out places to look for rare plants and other wildlife that is useful to getting those metrics. So it really is a really important starting point for the work being done in our parks here as well. So go download iNaturalist if you haven't already.
All right, that's great. In addition to the tree planting, are there efforts to support like other native plants? Because you talked about, some of the invasives kind of hindering that sometimes, especially after disasters. So what else is going on there?
Yeah, we do have regular weeding efforts out here in the park by our botany team as well. So those are other members of our natural resources team that come up here and are looking to support the rare plants that they find in the area. We actually, in the Colorado Desert District, have a whole herbarium, so we can collect samples of those to keep that genetic material and keep those samples through time, so we can have a long-term scope. We've kept that going for, I think, as long as the district has been around. So there's a really long span look back at the flora of the area, and we can use that to see how it's changed before and after. And that's been really important in figuring out how to reseed, for example, the forests here.
Okay, yeah, and where did that one go? So, with kind of the climate changing, are we expecting that the restoration will be pretty similar, or are there going to have to be some shifts to adjust for new conditions? Or, is there a I don't know, 50-year plan there?
Yeah, you bring up a really interesting point, and that's definitely been a consideration in planning these restoration efforts. Right now, all the genetic material on our plants comes from directly within the park because that is what we believe has evolved to best meet these conditions that we're currently proceeding with, again, to kind of keep that lighter touch in terms of what we're introducing to the area. I know that in the greater scheme of conservation biology and restoration ecology, there's talks with bringing in genetic material from areas we anticipate the climate is going to look more like in 50 to 100 years. So it's not something that we're doing yet, but again, we've still got those 700 acres to go. So I think that's an ongoing conversation that could be better answered by our environmental scientists, but I know that there's been comparisons with genetic material from similar species down in Baja California. So same species, but different distribution, and we're seeing that they might respond to things like drought and heat better, and those are things that we would expect more in the coming years. So we're going to keep monitoring our success of our reforested plants right now, and I think those options are on the table. That conversation is open, but for right now, we're keeping the genetic material to within what's been found within the park to make sure that we're not introducing anything new either at this point.
It sounds like a complex issue.
Definitely,
I'm sure we'll all be
definitely.
interested to watch that. Um, so we also have kind of questions about did you see the loss of that much forest? Like, did you see any effects on the local climate? Like, again, shortly after the fire versus now getting a little more
Absolutely.
vegetative cover?
Yes, absolutely. Some of you might be familiar with a term called evapotranspiration. Basically, that is a fancy word, another fancy scientific word for um, as trees breathe, they release moisture. So it definitely changed, I think, the microclimate of Cuyamaca Rancho State Park, of this region. Um, it certainly lends to hotter and drier landscapes. I mean, there is not nearly as much shade as there was. So if we're just talking about percentage shade and the effects that that has on cooling the environment, cooling the landscape, certainly it's hotter. Certainly. I guess I wanted to add, or just add a little bit too. If the orographic effect, it's still in play 100, 200 years from now, 300 years from now, I would think that this location could sustain, at the very least, that 2,500 acres that we're aiming for, and maybe even possibly more, to connect these stands up here on Cuyamaca down to Paso Picacho and other places throughout the park. But yeah, it's definitely a oh gosh, I lost my train of thought. Anyway,
This is a
what was
uniquely
that
suited
question again?
climate.
Oh yeah, sorry. Yeah, it definitely altered the climate in the short term and in local areas. Thank you.
So let's see. Also, when you had those figures about the normal fire regimes and how often the fires come through in different ecosystem types, and how much they usually burn, what point in time were those percentages from? Like before fire suppression, or mid 20th century, or when were those averages estimated there?
Ooh, I'd have to look at the data itself. I think we can bring it up. We'll get you an answer. I think that this was put together. Actually, I don't really know. I'm thinking.
Shortly, I gotta go scroll past those 3 videos of John Lovio to get at those source links, and we'll hear
Okay.
him introduce himself 5 more times.
All
So
right.
you can give me a
If
moment on that.
yeah, if
I
we
can
can
get
get
you an
a
answer.
yeah, if there's another question while Brianna maybe searches for that. Thank you,
I
Brianna.
know we're running
Okay.
short on time here.
Okay. How about so you're a state park. What's kind of your relationship with the federal government? There's national forest lands in the area, and different administrative policies, can change over time. So how do some of these factors affect your operations in the park and restoration efforts like this one?
Sure. So I mentioned that we are neighbors with Cleveland National Forest, and so we do have partners in federal agencies here, but being on a totally different reporting schedule, a totally different budget and everything. I can't say that our collaborative efforts are always totally meshing as close as would be ideal. Just because we're pretty distant in terms of the land area that they're managing versus our own. But we definitely try to partner with them as much as possible. And recently we did just host a summit up here talking about our reforestation effort. I know they were really interested in our success metrics because they differ a lot from what the U.S. Forest Service standards would be, because the land use goal is different for, Department of Agriculture is who oversees U.S. Forest Service. That's very different goals in terms of management compared to a state park and our mission, which prioritizes biodiversity, recreation, and kind of different outcomes. And so it's our goal to have ultimately a contiguous landscape. Once again, like we saw, we've also got private landowners to the north that are doing their best to restore. So I think it's an ongoing partnership, and one that we're doing our best to navigate despite whatever red tape that comes with. And I don't know, Will, if you have anything that you want to add, being up in the mountains more.
Largely, I think we're mostly unaffected. I mean, Brianna and I are here at work today, where I think most other national parks are shut down. So, yeah, in that regard, we're largely unaffected. I think maybe we might get a few extra visitors, perhaps. Yeah, I can't really speak too much to that, but yeah,
All right.
I think she put it that was perfect answer. Thank you, Brianna.
That's good.
Yeah, and I'm looking back at this fire table where I can send you a link if you want to give that person something
Okay.
in the chat. So here, I can put that in the chat myself and we can distribute that if you'd like. This is data from the U.S. Forest Service published between, it looks like 2007, 2012. I'm having a little trouble seeing clearly. I think it's a lot of different data sources coming into that, so I don't have a precise answer on what that's actually supposed to represent in terms of what fire regime is and land use is affecting the numbers they're coming up with. So I apologize for that.
Okay, let me see if I can paste that in here. And so if people wanted to support the park and restoration efforts, is there anything they can do? Like, can master gardeners help? Or, what are some of the options here?
We have we have a volunteer program. So that's one way that folks can get involved. We've got a trails maintenance crew. Of course, that's trails maintenance. That's less so on the side of restoration. I think the main way is really just through volunteerism. We also have a cooperating nonprofit, the Friends of Cuyamaca Rancho State Park, or excuse me, no. I'm thinking of Palomar. It's the Cuyamaca Interpretive Society. I think Crispia. Yeah, Crispia. They're our cooperating nonprofit. So I suppose if financially, if you wanted to contribute, you could donate to our cooperating nonprofit, and perhaps they might be able to, if it's earmarked for a particular project, like you want to donate and say that this money goes towards forest restoration, that's one way to do it. The other main way I think is just getting involved personally and becoming a volunteer. Master gardeners probably have a lot to teach us in terms of just, taking care of those little saplings, making sure that they make it all the way. Certainly, we could use all the help we can get.
Absolutely. Yeah, I definitely want to echo, no matter where you are in the state, your local state park likely has a cooperating nonprofit, and those usually are great with coordinating volunteers. Your state park may coordinate volunteers on their own as well, but I'd reach out to them, and that's the best way to make a connection, because our staff are always involved in those partnerships. And if you express an interest in something, I think we can usually find a way to get people involved. But it starts with being present in the park and expressing that interest as you're giving your time. So that's a great question. I really hope you're able to get involved wherever that speaks to you.
Great. Well, that is so great. And I think, is that about all the time we have, Emily M., for questions today?
I do think, unfortunately, we should wrap it up about now, but if there's any questions that we didn't get to, that you still want to put in the chat, we can gather those and maybe reach out to Will and Brianna later to see if they can maybe answer by email, and then we can send that out with the recording link.
We appreciate those questions.
Yeah, thank you.
Yeah.
Those were great.
Thank you so much. So yes, thank you again to Brianna Pinto and Will Meist for their wonderful presentation, and thank you so much to Emily Blodgett for monitoring our Q&A, and thank you to all of you for attending. If you enjoyed this presentation, please be sure to check out the library's events calendar for upcoming webinars. Next Wednesday, October 15th at noon, our law section will be hosting a webinar entitled Trial and Error, What Popular Media Gets Wrong About Trials. That should be a lot of fun. And then later in October, the California History section is hosting a webinar called Palabra, a conversation with comadre warriors of the Chicano movement. Should also be very interesting. You can also subscribe to our news and events newsletter for more information on upcoming webinars and other events in the California State Library. And if you're ever in the area, we invite you to visit the California State Library at 914 Capitol Mall in downtown Sacramento, Monday through Friday from 9:30 a.m. to 4 p.m. Check out our events calendar for information on tours being offered through October and November. And as always, you can send us questions via phone, email, and Ask a Librarian web form on the library's website. Again, thank you so much all for being here today, and I hope you have a wonderful afternoon.